Okay, everybody. So what we're going to be looking at today is section 1.4 in your book. And so what this section is about predicates and quantifiers. Now you're probably thinking, I have no idea what a predicate or a quantifier is. You're not supposed to, right? We haven't seen them before today. Okay, so what are they? So the idea is that you've learned a little bit of symbolic logic, right? You know what a preposition is? Sorry, proposition? Preposition? That's like a English thing, right? I don't do English. But you know what propositions are, right? So we know propositions. That's not words. All right, here we go. We know what a proposition is. And that's what we've been calling, like, P, Q, etc. So we know what a proposition is, and then we had like kind of connectors, right? That connected different propositions, right? So we had like operations or operators, like and, or, what were the others? Conditional, biconditional, exclusive or, and is that it? No, negation, and then that's it. And these are what we had here, right? Propositions, and then we had these operators, and we used the operators with the propositions to make what we called, compound propositions. But we can't do everything we need to do with just that. Now, the reason for that is we don't have a way to say that a subject has a property. Okay, that's something that we haven't dealt with yet. We don't have a way to say, like, object X has property P. We don't have a way to say that yet. And we really need that, because the whole reason we're studying logic, is so we can learn about proof techniques to prove mathematical theorems. And proof techniques, or sorry, not proof techniques, but mathematical theorems are generally structured in the way where they say, if object X has property P, then object X has property Y, or something like that. Okay, so we need to be able to do this. We need to be able to say that certain objects have a certain property. Okay, and that's what we're going to be dealing with in this section with predicates and quantifiers. Okay, so this is from the book here. It kind of awkwardly says what I just said. So what they're talking about here is, they say, so suppose you know every computer has a certain property, that it's functioning properly, and then you also know that there's a certain computer connected to the university network, right? So, like, what we're doing here, awkwardly, like I said, is this says all computers on network, I'm just going to say function. I'm skipping words to make it short. All computers on network function. And then down here, the next line says math 3 is a computer on the network. Right? So all computers that are on the network function, and math 3 is a computer on the network. And so you would be able to conclude that math 3 functions, right? Because all of the computers on the network function, and math 3 is a computer on the network, therefore computer math 3 must function. And we don't even have a way to say this in symbols at the moment. That's what we're missing. Okay, we need a way to say that computers have this property of functioning. we also need a way to say computers have a property of being on the network, right? And that's where predicate logic comes in. So it says it right here. So what we're looking at is predicate logic deals with the structure where you have a subject that has a certain property. That's what I was just talking about when I said object has property. Okay. So in an example here, hold on, let me change this size here on this highlighter. Driving me crazy. Okay. So when you're looking at something like this, x less than 2, right? Then what we're saying is x is the subject, and it has a property of is less than 2, right? So the subject is x, like we said, right? X is subject, but then also you have what we're going to call a predicate now. So is less than 2, that property is a predicate. Okay, so that's all we're talking about when we say predicate logic. Predicate logic has to do with a subject that has a property, and the property is called the predicate. So that's all there is. So like when you're looking at the next one down here, you have computer X, and then you have is functioning properly. So computer X, that's the subject, and is functioning properly, that's the predicate, right? And it's as simple as that. Subject and predicate. Predicate's the property. Okay. Now the point is that a predicate on its own is nothing. Okay, so it kind of says it right there, but I'm going to write it out. So a predicate is not true or false, right? That should be obvious, but think about it, right? As an example of that, let's just say is less than 3, or even x is less than 3. Let's write it that way. So that is not true or false. Okay. If you assign x to be a variable, so I'll say after you assign x to be a variable or a number. So after you assign x to be a number, then it can be true or false. Right? So if you fill in that x, if you take that x and you replace it with something like a number, so if you say like 5 is less than 3, then you could say that that of course is false. Okay, but you have to have a subject in there, otherwise it's not true or false yet. So a predicate on its own is not true or false. A predicate along with the subject is true or false, which makes it a predicate along with the subject is a proposition, right? Because it can be, it's true or false. So a predicate plus subject is a proposition. Now remember, proposition just means a thing that can be true or false, a statement of fact that can be true or false. Okay, so that's all I'm saying there. Now, how are we going to write these? Well, it's not actually that hard. So what you do is you write it like this. So you say p of x. So you say P of X, and then the X is going to be your subject, and then the P is going to be your predicate. Now, usually we use uppercase letters for the predicates. So usually any uppercase letter is what we use. Now, the reason I say any uppercase letter, not just like P and Q, because like normally we use P and Q and R for propositions. Well, for predicates, we're not going to do that because when you're dealing with kind of complicated statements in English, it really helps keep things straight if you can use a letter that somehow relates to what the sentence is. So like, for example, you might have like M of X, B, is taking a math class. And you might have C of X, B, is taking a computer science class. And then that way, when you see the M, it reminds you that M was math class and C was computer science class, right? And so that's why we want that freedom to just kind of just pick whatever letter there is. If you don't care, then, you know, you can use P or something. So let's look at this. So let's have a predicate here. So we have P of X, that's going to be a statement, is less than 3. It probably would have been better to write this way. Oops, not that way. Probably would have been better to write this as, again, same exact thing. It would have been better to write this as X is less than 3. That's how I should have written it. Okay, so what you want to be able to do is remember what I said. I said a predicate can be is true or false once you know what the subject is. So like here, X equals 2, that's going to make this predicate true, right? Because if you take this number here, if you take X equals 2 and you plug it right in there, then this is going to say 2 is less than 3, right? And then you say true. If you put in X equals 3, then it's going to say 3 is less than 3. And that's going to be false. And then if you put frog in for X, it doesn't make sense, right? You say frog is less than 3. And that doesn't make any sense, but you know, I'll call it false. The reason I put that in there was just to kind of point out the fact that, you know, you should be thinking of what kind of universe X is being chosen from. And so normally you would say, like up here when we said X is less than 3, maybe we just should have said like the real number X is less than 3, and we would know that X has to be a real number or something. X can't be a frog. Okay, so let's move on. Now, you can have a predicate that has more than one subject, right? So you could have like Q of X, Y, and you just have a statement that involves both X and Y, right? X equals Y plus 3. So, you know, we do an example here. So like, I'll work it out. The answers are right there, but so we have Q of X, Y, I'm just writing it again, is X equals Y plus 3, right? So if you know what X and Y are, you can evaluate that truth statement. I shouldn't have put that equals there. I should have done like something like that. Okay, so that's what Q of X, Y is. X equals Y plus 3. So when you evaluate Q of 1 comma 2, you have to put in the 1 and the 2 for the X and the Y. So you put in the 1 for X, you put in the 2 for Y, and then you have 1 equals 2 plus 3. And then you just say, is that true or false? Of course, that's false. I shouldn't use an arrow, huh? But that's false. And so if you pick a different one, q of 3 comma 0, again, you put in the 3 for x, you put in a 0 for y, so it says 3 equals 0 plus 3, and of course that happens to be true. So that's how you can check the truth value of a predicate. Again, you have to have a subject with your predicate, otherwise you can't do anything with it. So like q of xy, like this one right here, this is not true or false, right? Not true or false, because you don't have an x and a y, you don't have a subject. But once you put in a subject, then it can be true or false. Okay, and so that's fine. We just have predicates with more than one thing in them. All right, now let's move on and let's talk about quantifiers a little bit. So what quantifiers are how you, well, quantify things. That's how they get used. Sorry, not how they get used. They're how you indicate a quantity in like a mathematical statement. Okay, so there's a paragraph here, and we'll kind of look at that paragraph in a second. But just I want to think about what kind of stuff you see in math theorems. So you'll see things like this in math. You'll see like every real number has property, you know, dot dot dot, blah blah blah. You'll see things like there is a number x such that blah blah blah, some property. You'll see a statement like there is no number x with property blah blah blah, right? So these are the kinds of things that you see. You can, let's add one more. There is exactly one number x with property blah blah blah. Okay, and so every one of these has some kind of statement of quantity. So this one says every real number, but the key is the every. This one says there is a, which means one or more. Then this says there is no number, and then this one says there is exactly one, right? So you have every up here, you have none here, there is one, there is at least one, and then you have there is exactly one, and that kind of thing. I didn't get every single possible combination right there, but that's the idea. Okay, and so what those things indicating quantity are quantifiers, right? Indicate quantity. Okay, now obviously you can see where we need those for math, right? We're going to need to be able to say things like every odd number has this property. We want to be able to say there's no even number with this property, and so on. And so in order to say that, we need this idea of quantifiers. Okay, and so there are two. Well, yeah, there are two. So the two that we have is are what we call universal quantification, which is this one. Does it say that somewhere? Probably, but I'll write it. Universal quantification. Okay, so universal quantification is for all x, there is a property. And then down here we have this symbol, looks like a backwards E, and that's existential quantification. Yeah, you write that. Existential, how do you write that? Probably up here, right? Knew it was going wrong. Existential quantification. Okay, and so here they are, and you need to be able to read them. And so the way you read these, which again is probably somewhere else on this page, but the way you read this symbol is you would say, I mean, it says when it's true right there, but the way you read it is for all x, p of x is true. Okay, so when you see this right here specifically, this is what you need to know for all x. And the other one, existential quantification, looks like this. What that means is there is at least one x for which p of x is true. And so what you need to get out of there is that this symbol means there is at least one x. So that's why it's existential quantification. There exists one x. You could read it that way. So you could read it this way as well. You could say there exists an x for which p of x is true. So you can read it that way as well. So that's why it's called existential. All right. So let's see here. This is going to be a little bit more information about it. So they tell you that specifically this symbol is called universal quantifier, and you read it for all x. And so then they go to tell you where it's like what it means. So this statement here, this first one, for all x p of x, for all x p of x is true, that would mean that you can't find any x values for which this is false. Okay, so if you can find any x value for p of x where p of x is false, then that would be making this a lie, right? Because it says for all x, p of x is true. So any counterexample would be a counterexample. Okay, we'll see what to do with that in a little bit. All right, well, let's try to write these. How can I do this? Hold on. I know what I'll do. How big is that? Whoa, big. Okay. Haha. Being sneaky. I'm writing over the answers before you see them. Oop, you saw it. It's a trick. It won't let me write. Don't read it. Don't read it. Aha, it's gone. Don't read it. Redacted. If I'd been smarter, I would have done this before we started. redacted. Okay, lots of redacting. Let's look at these examples. Okay, so what we've got is a bunch of quantifiers here, or predicates here actually. We've got predicates and quantifiers. And what we want to be able to do is we want to translate these into English. So what do we got? Let's, P of X means X is your friend. We'll highlight these in different colors. Q of X is a computer science student. Okay. And then remember what the quantifiers do. Okay, so assume that the universe of discourse for X is the set of all people. Now, what we're actually going to need here is, yeah, okay, that's right. We can use people. You could have had the universe of discourse. That just means what kind of things we're choosing the subject out of. That's to keep you from, remember when we had like X is 3, X is 2, X is frog? We don't want to have X is frog. So we're only talking about people here. If you let everybody know that ahead of time, then you don't have that issue of using the wrong kind of subject. Okay, let's try to write these out. Let's not babble about it. Okay, so let's think about how to read this. So we know what this symbol, we know what this symbol means, right? Oh, it's still kind of big. Okay, let's try that. We know what this symbol means. This says for all or for every. So this would say for every. I don't like that. I'm gonna switch to even finer point. Okay, for every X. Okay, but what is X, right? You have to know what X is. X is the set of all people. So we shouldn't say for every X. You should say for every X, but X is people. So for every person, X. So for every person X, P of X is true, right? Now I'm going to write that, but then I'm going to change it. Right? So for every person X, P of X is true. Now we know that that's what the universal quantifier tells us to do, right? But what is property P of X? Because you don't want to really say it this way. What does it mean for P of X to be true? So you look up here and you see that P of X is your friend. So for every person X, X is your friend, right? So for every person X, X is your friend. Now, once you write it out that way, for every person X, X is your friend, you can try to find a better way to write it in English. So for every person X, X is your friend. So every person is your friend. Or, yeah, for every person, the person is your friend. So when you think about it, you can come up with the best answer as, everybody, or every person, however you want to say it, whatever sounds best, every person is your friend. That's how I would write it. Okay? Oh, all people are your friend. Every person is your friend. Close enough, right? The same meaning. Okay. Now, notice that we can combine this with compound propositions. So let's translate this next one. Oh, sorry, I was looking at C. Let's look at Q. So here's Q. So, of course, this says for all X, so that's for every X, Q of X is true. Of course, that's the direct translation, right? But then what does that actually mean for us? So for every X, but X is people, right? So how would we write this? For every X, that's for every person. So for all people, or for every person, I'll even say person X, which we normally wouldn't do. For every person X, Q of X is true. Well, what's Q of X? X is a computer science student. So that's true. So for every person X, X is a computer science student. All right. Now that's a very awkward sentence, right? For every person X, X is a computer science student. So we don't want that. You want to say it nicer, or better. So how do you say that better? For every person X, X is a computer science student. So that would just be every person is a computer science student. That's how I would write that one. All people are computer science students. Yeah, that's fine. All right, now let's look at this next one. So this next one has a compound proposition. We have an or there. So this one says, direct translation says, for every X. Now, when you have P of X or Q of X, that's going to mean one of those is true. So or both. For every X, P of X is true, or Q of X is true. And with English, probably you've come across this already, right? The problem with or in English is that usually when you say or in English, you mean one or the other, but not both. So normally when you say or in English, you mean exclusive or, not regular or. So it's probably best to write this for every X, P of X is true, or Q of X is true, or both. Okay. You don't technically have to add the or both, but it makes it more accurate in English. So I'm just going to write it that way. So for every X, P of X is true, or Q of X is true, or both are true. Okay. Now, how are you going to say that? Well, we should be able to do this a little bit faster than the others because we already know what P and Q are, right? P was X is our friend. Q is X is a computer science student, right? So what this is saying is for every person, the person is your friend. Now I have to keep saying your friend because of the way this was worded is awkward. I said X is your friend, so I can't really change that word. Who's your? Am I talking to you? Am I talking about myself? I don't know, some third party, but they use your, so we're using your. For every person, the person is your friend. That's P of X. Or Q of X. What's Q of X? Is a computer science student, right? So for every person, the person is your friend, or they are a computer science student. Or both, right? They can be both. They can be your friend and they can be a computer science student. It's unlikely because computer science students don't have friends, but it's possible. All right, and you see that in this official answer, so to speak, I didn't bother to say or both. Okay, now let's look at the next one. Again, we got another operator in there. We have a conditional statement. So what does this say? So again, we have to use, do it in 2 tries. So this says for all X. So for for all x, or for every x, comma, q of x implies p of x. But a better way to say that is if q of x is true, then p of x is true, right? Q of x implies p of x, that's if then. So write it as an if then, and then after you write it as an if then, for every x, if q of x is true, then p of x is true, then we can translate that into what it means. So in English, what does this mean now? For every x, again, that's every person. So for every person, if q of x, what's q of x? Q of x is a computer science student. So for every person, if the person is a computer science student, but I'll just say if they are a computer science student, then p of x. So what's p of x? P of x is your friend. So for every person, if they are a computer science student, then they are your friend. Okay, so you got to be able to do this. So we got like if q, there's if q, then p, then p. Okay. What's the official answer? Any person that is a computer science student is your friend. So that's more concise. But you don't have to be concise, you just have to be able to do it. So for every person, if they are a computer science student, then they are your friend. That has the same meaning as if a person is a computer science student, then they are your friend. So you can write it that way. Okay. Now we haven't done any that used an existential quantifier, so let's make sure we know what that means. So backwards E looking thing, existential quantifier, what's it mean? It means right here, when you say there exists an x, there is an x. Now it says there is an x, that means one or more, right? Like if I say, you know, how should I put it? Let's say I have a package of Twinkies. I don't, but I wish I did. So you have a package of Twinkies, right? And if somebody says, is there a Twinkie? And I say, yeah, there's a Twinkie in there. That would be true even if there was 5 Twinkies, right? If there's 5 Twinkies in the package, then I would be correct to say there is a Twinkie in the package, even though there's 5, right? So, yeah. So that's right. Let's continue on here. I'm trying to hurry up. I have 10% battery life. Oh, 9% battery life. Okay, let's hurry. So what does this mean? This means there is at least one x for which, and then you have q of x and p of x. So that would be for which q of x is true and p of x is true. Okay, so both of those are true for at least one x. So now let's write that in words. There is at least one x. X is people. So there is at least one person that has property Q and has property P. So property Q is that they're a computer science student, and property P is that they are your friend. So there is at least one person that is a computer science student and is also your friend. Now, the word also is not part of the statement, but it's just how to say it in English, right? So P of X is true is your friend. Q of X is true is a computer science student. And just also is just a better way to write it. So that's my answer. Interesting. We'll box it like that. That's weird. Okay. All right. 1 second. Sorry about that. Just had to run across the room. Oh no, I failed again. 8% battery life here. Countdown is real. All right, last page. Okay, what does this say? So this says, uh-oh, look at that. There's a not in front. So that says there is not in X for which. And then we have this. This is very complicated. There is not an X for which P of X is true. And then look at this, not Q of X. So not Q of X would be Q of X is false. So there is not an X for which P of X is true and Q of X is false. Now what's that mean in words? Well, in words, that's going to be there is no person, right? There does not exist an X. So there is no person, not exist. There is no person that P of X is true. P of X is your friend, right? So there's no person that is your friend. And Q of X is false. So Q of X is false. So Q of X is a computer science student. So false would be is not a computer science student. So there's no person that is your friend and is not a computer science student. Okay, let's look at this. Yeah, and you can simplify that all the way down to all of your friends are computer science student, right? Because no person that is your friend is not a computer science student. So that means all of your friends are computer science students. All right, almost done. So how would we do something like this? Write a logical statement using quantifiers and predicates. Everyone is going to the movies. Now you have to be careful about this, right? You don't have any symbols, so you have to make the symbols up yourself. So you say something like this. X is people, right? Universe of discourse. What are we talking about? Then we need a predicate. Is going to the movie later. So you go P of X is going to the movies later. All right. So with that in mind, how would you say everyone is going to the movies? Everyone is all X. So you would just say for all X, that's all people, they are going to the movie theater. That's it. For all X, P of X. Okay. Okay. I used M for movies. Remember what I said? A lot of times they'll just use a letter that reminds them of what they're doing. All right. None of my friends are going to the movies later. So there's several ways to do this. How are we going to say none of my friends are doing something. So I'm going to write a couple ways. Here's one way to do it. None of my friends. You could say there does not exist in X for which P of X is true, right? That says there is no X are people, for which P of X is true. So that's fine. There does not exist a person for which P of X is true. Another way to say it is, none of my friends are going to the movies later. You could say, for all X, P of X is false, right? If P of X is, if P of X is going to the movies later, then not P, right? Not P of X would mean X is not going to the movies. Right? So you could say for all X, P of X is false. So that would read for all X, for all people, not P of X. See? So you could say for all X, P of X is false. That would mean everybody is not going to the movies, right? So directly translated, this says everyone is not going to the movies. That's what this one says. Whereas this one up here says something slightly different. This one says there does not exist somebody. So this one says there is no person that is going to the movies. Right? So they mean the same thing, but they're written in a different way. There's no person that is going, or everyone is not going. So it's where the negation is, right? Do you want the negation out front, or do you want the negation on the predicate? So in front of the quantifier or in front of the property, whichever one you want. All right. How do we do it? Oh, whoa. Sorry. I screwed that up a lot. Back this up. I didn't even pay any attention to the fact that it was friends. Back this up. Okay, we got to redo this. Sorry. I did people, but we were supposed to be doing friends. All right, try again. We'll do this again. If my battery lasts. I really hope it does. 5%, guys. You can't see it, but I can. All right, try again. Okay. So none of my friends are going to the movies. So we do need movies, right? So we will use M of X is X is going to the movies. And we need a friend. Let's use P of X for X is my friend. I could have used F, right? X is my friend. All right. So again, there are a few ways to do this. So none of my friends are going to the movies. So I could say for all people, let me write it like this. Let's say for all people, if they are my friend, then they are not going to the movies. I don't care if it is 15 cents. Right? Because none of my friends are going. So if they are my friend, then they are not going. So this is a way to write it. So then if you want to translate this, you would say for all people, that'd be for all x. Then you have if they are my friend, that would be what's friend? P of x. If they are my friend, there, then they are not going to the movies. So that would be implies not movies. So for all people, for all x, if they are my friend, then they are not going to the movies. So P of x implies not movies. Friend implies not movies, right? That's what I'm saying here. Friend implies not movie. That's one way to do it. Okay, and there are other ways to do it. But let me see, can I think of one real quick? What's the way it was written originally? None of my friends are going. So another way to do that would be, let's get rid of this. How would I say none of my friends? So I would say there does not exist a person that is my friend and is going to the movies. That's another way to say it, right? There does not exist a person, right? Because none of my friends are doing that. So there is not a person that is my friend and is going to the movies. So we need there does not exist a person is my friend is going to the movies and somehow another color and. So how do we write this? There does not exist a person. Not exist person parentheses is my friend. Friend is P. Is my friend and is going to the movies. Movies is M. And then there's an and right there. So there does not exist a person. There's not a person where P of x is true and M of x is true. No people that are my friend and are going to the movies. So that's another way to say it, right? So you can't tell if you're right necessarily just by looking at the right answer, because you might have a different answer and your answer is still correct. Okay, so I think that's it. Let me delete this. And yeah, so that is quantifiers. There might be another lecture where I answer some trickier questions for this, okay? But I think that's it for now, so I will talk to you guys later.